Okay, so here we're going to talk about graphing by hand. So again, this is something you have been doing since you learned to graph. You actually started out graphing by hand. So I want you to use whatever techniques you want, and then we'll discuss what some are better than others. But I want you to graph the equation negative x squared plus 6x minus 1 by hand. You know, when you say by hand, then you should have 5, 6, maybe even 7 points plotted. Sometimes you can't, though. It depends on what the equation is. So do your best. Pause the video. Graph this by hand. Unpause when you're ready to check your work, and then we will have a discussion about describing any features about the graph that we see. Okay, so hopefully this is what your graph looks like, and hopefully you did something along the lines of what I did by making an XY chart or a T chart, depending on what you want to call it. So basically I just chose some X values, plugged them into the equation, got the Y values, plotted those points, and then connected the dots with a curve. Now, don't be thrown off by the fact that I use a dashed line. I was just trying to make my graph very pretty. The actual curve is a solid line. So I apologize if that's confusing. I was just trying to be fancy with the tools that I have. So anyway, how do we do this? Well, we just plug in some points. Now, a couple things we want to discuss now, things we want to think about. And some of this is actually things that hopefully you thought about before you started to graph. And so things like, what is the shape of the graph? What is it going to be? How do we know that ahead of time? Well, now that we can see the graph, we can see the shape, but hopefully we recognized from the equation. So can anyone tell me what the shape of the graph is? Parabola. Very good. And we also know, and we can see this, but hopefully we knew ahead of time, that the parabola opens down. How would we know that without graphing it? Well, it's an x squared. That's what tells us that it's a parabola, so it's a second-degree polynomial. And the leading coefficient is negative. That's how we know that it is going to open down. Can anyone tell me something else they notice about the graph? Symmetry. Very good. If it's a parabola, all parabolas are symmetrical about some line. So we have some imaginary line of symmetry. That line is going to go through the vertex of the parabola. Well, why do we care about that? Well, we might not, but in this case, since we know this is going to be a parabola, and we know it's going to, therefore we know it's going to be symmetrical, notice that I stopped plotting points once I got to the point 5, 4. But I would know without doing any work, and just because of the fact that it's symmetrical, that if I was to plug in 6, I would end up at -1. And if I was to plug in 7, I would end up at -8 because of the symmetry. So symmetry, understanding that there is symmetry in a graph can be helpful when you are trying to plot it by hand. Anything else? Y-intercept, very good. So we can also see from plotting this by hand that we have a y-intercept at the point 0, -1. We can see that we do cross the x-axis, so there are x-intercepts, but within our graphing this by hand, we did not find what those exact values are. Could we? Yes, but for the process of this problem, we don't need to. So, again, with graphing by hand, you're basically just plugging in points. If it's a function, you can plug in x values and find the y values. If it's not a function, you might have to plug in y values to find x values. But things you want to think about or be able to understand and discuss is, what is the shape of the graph? Is there any symmetry? And any intercepts? And we're going to talk about intercepts more in our next video.